And the second part of the fundamental theorem of calculus is about computing the integral. And I will use the first part in the sense that instead of computing an integral of some arbitrary function f, I would like to compute an integral of the derivative. Oh, maybe prime of x dx. You'll see later that this computation can be done much easier. How can I integrate from a to b? And now a and b are some numbers. We treat them as constants. I'm interested in computing this. And I will proceed by definition. The integral is limit as delta x goes to 0 of those sums over I of what? F prime of xi times delta x. Right? I put the function I'm integrating, that derivative, and evaluate it at some point xi in the ith interval. But this expression means something to us. If I just put arbitrary function f instead of f prime, for a function f, the product of f times delta x doesn't mean much. But the product f prime times delta x means something. What does it mean? Derivative at some point multiplied by the change of x. Well, the derivative itself is the change of f divided by the change of x, right? So if you multiply derivative by the change of x, it means, right, it cancels. So it means delta f. It means the change of f on that ith interval. So the meaning of this summand, ith summand, is the change of the function f on ith interval. Total change. Now, what happens when we add the total change of the function over the first interval, plus over the second, plus over the third, plus over... Oh, you should go left to right for you, right? First, second, third. So you have a function. Now I'm sketching the function f, right? Now I'm looking at the long interval subdivided into pieces, and I look at the first piece. Where is my delta f? Delta f is the change of the value of f as we go from left to right. Right? So this is delta f. Delta f1, right, on the first interval. It's how much the value changed over the first interval. What happens when I add, well, where is the change of f on the second interval? So you go from here to there, and you look at the y coordinate, right? And that becomes delta f2. Measures how much the function has changed over the second. What happens when I add those two? It will be the total change over the whole interval. Is it not? Well, let's check it algebraically. If you have a hard time visualizing that, let's call this point x0, that point x1, that point x2. What is the total change delta f1? It is f of x1 minus f of x0. That's exactly what it is, right? What is delta f2? It is f of x2 minus f of x1. What happens when I add these two together? Cancellation. That's what we do the whole class, right? We cancel here and there. So we cancel f of x1. And what we have is f of x2 minus f of x0. Right? And the meaning of that is what? F of x2 minus f of x0. It is the total change over the union of those two intervals. Now what happens when I add delta f3? I'll have to look at the next. Yes. So it's f of x3 minus f of x2. And when I add those together, f of x2 will cancel. And the meaning of the result will be f of x3 minus f of x0, the total change over the whole union. And then they keep adding things, right? And they keep having the total change. And when I come to the very end, and the whole sum over all i's from I equals 1 to n.
But the last one.
Do we know what that number is?
B.
It's b. That's right. And x0 is a. Right, so what we will have is limit of f of b minus f of a. Now can you find the limit of f of b minus f of a as delta x goes to 0? What happens to this quantity as delta x goes to 0?
Or does it, like, is it the x portion of the
Delta x? No, it's not. Well, b is some number we had in the integral, right?
Oh, okay. I didn't know.
And a is some number we had in the integral originally, right? We introduced delta x much later, so delta x doesn't even show up in this equation.
Yeah, because it doesn't matter how wide the interval delta x is, because it's, no matter how many intervals you have, it's going to end up being b minus a.
Exactly. So the limit of this is exactly f of b minus f of a. So that kind of limit is very easy to find. If you're looking at the limit of something as delta x goes to 0, and that something has no delta x at all, well, that something remains what it was. So what we have is an explicit formula for the integral. We don't have any integral anymore, right? So what we just computed is a way to compute the integral if you're integrating the derivative of something. Right? So what it boils down to is, if someone gives you an integral, you have to look at what you are integrating. You have to find the function f such that what you are integrating is derivative of that f, and then use that f to subtract the values.